At the outbreak of the Second World War, the average infantryman carried a bolt-action rifle as his primary tool, a weapon that defined the limits of individual firepower for decades. Every major power relied on these manual designs. The British Commonwealth used the Lee-Enfield, the United States issued the Springfield Model 1903, and German forces carried the Karabiner 98K. To fire, a soldier performed a specific mechanical sequence, pulling the trigger, then physically unlatching the bolt, drawing it back to eject the spent casing, and pushing it forward to chamber the next round. Reloading was equally manual, requiring the soldier to press a physical clip of ammunition directly into the top of the magazine. While these rifles were accurate and lethal at long distances, this hand-operated cycle was too slow for the high-speed, mechanized environments of 1940s combat. Armies realized that to survive, the individual infantryman needed a much higher rate of fire to match the escalating speed of the battlefield. Engineers faced a massive obstacle: physics. Standard rifle rounds at the time were heavy and powerful, generating intense recoil energy that pushed back against the shooter with every shot. Harnessing that energy into automatic fire required building massive weapons. Heavily built heavy machine guns were used in dugout positions because their sheer weight could absorb the violent shock of continuous fire. Even the light machine guns, intended to be portable, remained bulky and difficult for a single soldier to control without specialized training and a stable firing position. The lethal value of this speed was proven by weapons like the German MG-42. Capable of firing over 1,200 rounds per minute, it earned the nickname Hitler's buzzsaw for its terrifying effectiveness. This created a design deadlock. An engineer could provide a portable bolt action with long range, or a heavy machine gun with automatic speed. Attempting to combine both into a shoulder-fired weapon resulted in recoil that was impossible to manage. The first attempt to bridge the gap was the semi-automatic rifle, featuring designs like the American M1 Garand and the Soviet SVT-40. These weapons used gas operation. As the bullet travels down the barrel, high-pressure gas expands into a parallel tube, physically pushing the bolt back. This internal automation removed the manual bolt cycle. A soldier could fire as quickly as they pull the trigger. While gas operation eliminated the manual delay, it remained limited to one shot per trigger pull, failing to reach the volume of true suppressive fire. While some designers worked on gas-operated rifles, others looked toward the submachine gun to provide forward automatic fire. The engineering trick was to abandon the heavy rifle round entirely. Instead, submachine guns were chambered for smaller, low-recoil pistol ammunition. Because pistol rounds produced less kick, weapons like the Thompson, the Sten, and the Soviet PPSH-41 could be controlled while firing in full auto mode. These were cheap to mass-produce and devastating in close-quarters combat, making them ideal for paratroopers and resistance groups. However, the submachine gun had a fatal flaw. Pistol ammunition was inaccurate and ineffective at standard battlefield distances, leaving the primary infantry problem unsolved. Late in the war, German engineers attempted to create a hybrid weapon, combining the range of a rifle with the rapid fire capability of a submachine gun. The solution lay in a completely new type of ammunition, the 7.92 by 33 mm Kurz, or short round. This diagram shows the intermediate scale of the innovation. It sat directly between the massive traditional rifle cartridge and the tiny pistol round. This medium size was just right. It reduced recoil enough to allow for full auto control, while retaining enough gunpowder to remain lethal at mid-range distances. Shrinking the bullet finally made true automatic capability practical for the everyday infantryman, ending the decades-long dominance of the massive rifle cartridge. The weapon built specifically for this new round was the German Maschinenpistole 44, better known as the STG-44. Its functionality was dual-purpose. It offered semi-automatic precision for distant targets and fully automatic fire for close-range suppression. The STG-44 broke the rigid binary that had long separated the roles of a rifle from those of a machine gun. By combining gas operation, intermediate ammunition, and selectable fire modes, it established an entirely new tactical category, the assault rifle. The STG-44's design provided the foundational blueprint for modern infantry. Its inclusions directly inspired the Soviet AK-47, changing the way squads are armed and how infantry combat has been fought ever since.